right? We're going to use the junction rule. We know, and remember, these are students, right? So what? Let's go with. Well, no, we can't go with 8. Whatever. Like they're coming out of here. We'll just make these like 60 students. So if 60 students come out of here and 40 students go down this path through 3, how many had to go up here? Yeah, so that's got to be 0.2 amps, yes? Looks like a 1. Okay, now, please notice this. If 40 students went through this, and then straight down the hallway is 32 students, what must have happened through 5? It must have gone like that. Does that make sense to you? Right? 40 kids came into this junction. 32 kept walking straight ahead. We better count for those other 8. They can't just disappear. And now we know this to be 28 amps. I mean, 0.28 amps.
That's 0.2 and 0.8.
Right? Very good. You hear what Max is saying? And you did it with his hand. 0.2 is coming this way. 0.08 is coming that way. It must be 0.28 that way. And then now, look, do we have 0.6 coming back to the battery? Yes. Remember, people don't get used up. School's not that hard. It doesn't physically consume your body. So there has to be the same number going out as coming in here. It could. It's just this situation is set up by the resistances, which we don't specifically know. By adjusting the resistances, I can cause the current to flow any way I want to. Wait, so wait, you're saying why couldn't it go this way? Yeah, the only reason we know it's going up is because of these two, because we were given this, right? Like it's not possible for anything other than this to happen in this situation. Do you see that? Yeah, because that diminished. But yeah, go ahead. I'm not sure what you're saying. Oh, my fault. Why can't 1 go through 5? Because if 1 goes through 5, then, well, first of all, then if 1 goes this way, you're saying the current has to go down. If this current, let me do this in blue, if this current goes down and this current's coming this way, that means this one, I4, has to be the sum of I3 plus I5. Right? It has to be. Do you see that? What's that? So, I mean, and 3 can't be going to the left because, okay, yeah, 3 is ever okay. Well, let me do this. I'll come with this one. Everyone sees that the current flows out of the positive side of the battery, right? When it hits this spot, what are the possibilities? Yeah, it can go right or up, right? Now, it is possible that one of these could actually flow into that current. Do you get what I'm saying? It is possible that this one could flow this way and they both go that way. Right? That's within the realm of like reasonable possibility. But don't look at the rest. Just look at this junction. Right? If I throw you, good God. If I throw you a junction like this, there are certain possibilities. You have this one, you have this one, you have this one, right? And that's pretty much it. Because basically, this in, that's not a good color. This in is immutable. We can't change that because that comes from the positive end of the battery. But both of these could be either way. Just certain things lock us in. If this one is down, this one has to be that way. Does that make sense? If this one is this way, this one has to be that way. Yeah, but of course, we could have both of them go that way. Right, that's okay too. So those are all the possibilities. So now when we look back at our circuit, we say they told us that this was 0.4 amps. But I think as Anne was intriguingly trying to say, what if this 0.4 amps was going to the left? No? Can come from either 1 or 3? Okay, true. If it goes through, no, I think she's saying or, right? Because it can't go in 2 ways at once. Because, oh yeah, okay, okay, thank you. I finally get what Anne's question. You can't have flow. Why can't you have current flowing 2 ways at once? Why can't half of the wire be, you know, I mean, why not one half of the wire be current one way, one half of the wire be current the other way? What's that? Yeah, it's, see, what drives the current in the first place? Electric fields. It is the concentration gradient that of electrons that produces the electric field. Very high electrons, very low. The fact that this section of wire has more charge than this one drives the charges this way. Right? Does that make sense? Because they don't want to be where there's more charge. So what's going to happen is the concentration gradient of charges is going to drive things in one direction because it's connected by 2 things. Right? And I know that, you know, generally we're sort of, we sort of dislike one direction, but but in this case, we have to accept it as a hard fact of life. That something flows because of the yeah, okay. Like it flows because of the difference in charge densities on both sides of the circuit circuit component. Does everyone kind of get what I'm saying? Right? Like if I'm walking down the hallway and I get to this junction where I could go this way and this way, what's going to make me choose? It's going to depend upon where the less concentrated electrons are. If I'm a positive charge, okay, there is no positive charge, but let's have this frictional positive charge cruising through the circuit, and I go here, then wherever wherever I see the concentration gradient more positive, more appealing to me, that's where I'm going to go. Kind of get what I'm saying there? So that's what happened here. We were told that this is true, therefore this one must have gone up. And since, like at this point, because charges went through here, this electric potential drops. This one's going to drop. We know that like this electric potential drops bigger than that one, and that pushes things this way. Yeah. Yep. Points, yeah, sure. Do you see it? That's very good. Everybody see what Jasmine's noticing? This 0.2 and this 0.4 is 0.6, and this 0.28 and this 0.32 is? Yeah, so what's happening is this is some sort of combination. So if I go like 0.4 minus this plus that, and that's still 0.6. Right? Because you have to include, like, if I include this, then I have to include it the right way. Yeah, because this current lost that way. And then you can go this way, boom, 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 right? I can go 0.2 plus 0.08 plus 0.32, that gives you this. And that's because these two are coming together. Right, so no matter how you slice it, right? This piece of time, or whatever, this way or that way. It doesn't matter how you slice it. It's all going to come out to be the same current because current is conserved. Because current is charges and charges are conserved. They are matter, and matter is not created or destroyed in a non-relativistic framework.
That's all we're hearing. Science, physics, still want to know.
Brendan. Okay, any questions on that one?